Hi, welcome back. This is a very quick sandbox episode. I'm currently doing a playthrough on YouTube to try and get the Raining Bullets and the No Logistics awards. Once I've done that, I'm hoping to turn that world into a purely bot-based megabase. And we're playing around with various bot builds. It's very tempting to round things up so that your build is nicely shaped. But that means you've got overproduction. And overproduction when machines are just kept idle is a sad thing. So I've been thinking about ways that we could cope with overproduction without having idle machines. And the first thing I came up with was to basically monitor how much material was waiting for trains to take it away to the next site. And when it crosses a threshold, cut the power. So then at a later date, when the materials fall below another threshold, a sort of lower panic threshold, the site would then be turned back on. And I've got a feeling that this will let me over budget 10 to 20% on capacity. But because particular sites will be coming off and online, I will not be at any one time hopefully overproducing too much of anything. Okay, so to do that, what you need is some trick to turn a build on and off. And that's what I've mocked up here. So this is the world, it's in sandbox. I'm mining coal, it's going into this power generator. Then I'm mining some iron ore, totally overkill. It's then going into a furnace, which I have beaconed to hell and back. Now, I'm then, for the sake of testing, turning the iron plates from that into iron bars. And I've got a big buffer here so that basically we'll be able to make iron bars until the heat death of the universe. We're bringing power down here into this arrangement. And for the sake of argument today, the iron bar making fabrication area is permanently on. What we want to do is turn off smelting when our buffers fill up. So what we have here is a chest, and this chest is our buffer of iron. So we're buffering up iron. What I want to do is set it up so that it is going to buffer up to 200 plates. Then once it's reached 200 plates, the smelting will be turned off. This will then chew through its buffer of iron until it gets down to less than 100 plates. At less than 100 plates, it will turn the smelting back on. That way we can run the smelting at peak efficiency and only have it running when we need it running. So I'd rather run the factories at peak efficiency part of the time than at partial efficiency all of the time. The way we do this is with an SR latch, and there's a trick to building these things. All right, so what we have here is S, that's our set signal, and that is going to be on when we have fewer than 100 plates in our box. Right, so you can see it flashing on and off because we got down to 100 plates. Our reset signal is greater than 200 plates, and again that outputs a single R. So we're outputting a single S when we're under 100 plates and a single R when we're over 200 plates. That gives us our boundaries. Could have used less than or equal to's, greater than or equal to's. I just used less than, greater. We're moving things with a stack inserter, so it's a pretty blunt instrument doing the counting anyway. Okay, then we've wired the box up with a red wire to these two. That's bringing in the iron plate counts. We're then wiring up the outputs of this, which is the S signal or the R signal, and piping those into these lights. So this light is on when R is non-zero. There it is, it's just gone on. This is on when S is non-zero. Okay, so this is the reset. What this does is clears a memory of S further down the circuit. So we take a red wire out of this and put it into a decider combinator. And this is the trick. This is the bit you have to get your head around. So this one is wired up so that whenever the set signal is greater than the reset signal, you output one set signal. Straightforward. So whenever we hit less than 100 plates, so 95 plates, we would output an S here. We wouldn't be outputting an R because R is only going to happen at greater than 200. So we put an S into here. That's great. So this will output an S. Light up this light and turn on this switch because this is set up for wherever an S is greater than 1. We then, with a different coloured wire, and that's really, really important, so I'm using a green wire, you wire the output to the input. And what that does is on each game clock tick, it takes the value of S from the previous clock tick, so our 0 or 1 S's output here, and feeds it into the input. So last clock tick, if we had an S, we would feed an S in as input. All other things being equal, that means we now have greater than 0 S's coming in. So once you've turned S on, this is going to latch into the on position. So you can see the S light here is on, even though the S light here is not on. So this will be looped on an S of 1. Then this eventually triggers because we have more than 200 items in here. You can see there's more than 200 items. That's the reset signal. Right, when you're resetting, you'll have had an input of 1S coming back down the green wire, the loop, and an input of 1R from the reset. So then S is not greater than R anymore, so it outputs nothing. It does not output 1S. So that's cleared the memory of S. So then we feed the output into the input, but there is no output in this case, so there's no input. So S is not greater than R because we're not feeding in any input. So then that latches to off until we externally push in an S because we're down to 94 plates. Right, so you can see we're putting an input of S from here, and this will actually have an input signal of 2 S's, one from its memory and one from here. So it's like a logical AND by doing it with these thresholds, or a logical OR. So then that latches onto on again, which then activates this electric switch, which is set to is S greater than 1, and the smelting starts up again. So let's watch this for another couple of cycles. So we are smelting iron. The iron is being fed into this chest. This chest has 150 items at the moment in it, 160, 180. Yeah. So you can see the S is feeding around, the power is on. And 190, it might get it next time. 200, so reset got hit. That cleared the S which was looping around here, turned off the power switch, turned off the smelting. There's now no longer any extra plates coming in. So the plates in this box are being chewed through ever so slowly. I tried setting up some rigs which showed this quicker, but I couldn't find a good balance of production and consumption rates where we could show it. So that's down to 150, 140, 130, 120, 115, 104, and we're about to get the set. There we are. And the power's on, the smelting's back on. There you are. Okay, so if we look at production, you can see these you've got these cycles of consuming ore, of producing plate, and then consuming plate, and ultimately producing iron bar, which if we turn everything else off, whoops, that was the wrong button. You can see the iron bar production is absolutely dead level, as is the iron plate consumption. So we've managed to smooth out bumpy input, produced absolutely smooth output just by using the SR latch. So in a real world, the plan is these days I tend to have train stations which monitor how much there is stored in their chests. so you count the chests. I then divide it through by the stack size and chest capacity, and that gives me an integer number of trains, which can either pick up or drop off before the chests are used up. So I'm just going to set up some SR latches so that trains run between a minimum and maximum number of buffers in there. So between, I don't know, 4 and 10 or something like that. So what that will do is turn the factory on when the products waiting to be picked up from the station dip below 4 train loads. The area will then generate stuff until it has buffered up to 10 train loads. At that point, the whole area will turn itself off. Trains will keep on arriving, picking stuff up. When it falls below the threshold again, then the power for that area will be turned back on again, and so on, rinse, wash, repeat. And that will allow me to run my individual modules at full throughput whenever they are running, and guarantee that we're not burning resources or, well, basically electricity and cycles whenever there's no work for them to do. Because the last thing I want to be doing is running a whole load of modules and beacons and inserters and assembly machines chewing away CPU when there's no work for them to do. Okay, so that's it. Thanks very much for watching. So these SR latches are really tricky to get your head around, but really simple to make once you do. It literally is, you have 2 input signals. We could call them F and G. So you do F is greater than G, and we would output 1 F. So F is your on signal, G is your turn it off signal, and then we just need to wire it in whichever type of wire color you want to use, like that. That is then going to latch the F, and then you need 2 inputs. Doesn't really matter what type of thing you have inputs from, but the important thing is that you use a different color wire to wire those in. One of these is going to be your lower one, and one of these is going to be your upper. So we probably want to use these deciders instead. Let's do that. Yeah. So wire them to the input. Then you want one of these to be a lower threshold. So I don't know. Reds are less than 50, and you want to output 1F because we're going to turn everything on. We will turn things on when the number of red undergrounds dips below 50. Then this one is going to be your upper threshold, so we probably want to set this also to undergrounds greater than 1000. Okay, and we want to output 1G. So now whenever you have more than 1000 undergrounds, G will be sent. That will clear this and turn off. Let's imagine we're doing, there we are. Let's do it like this. So we have an assembler, we would have a inserter, right, and this is enable disabled on F greater than 0. Okay, so that would be the basic intuition about how you manage these latches. And that's it, really. So thank you very much for watching. I hope you enjoyed this. It's a fairly simple technique, but it's one of those ones that's a bit of a brain teaser to work out yourself. Again, the important thing, on your latching decider, you use 1 color wires to bring in the inputs and to take out the output, and then you use a different colored wire for the loop back to provide the memory, and it is the set signal that you output. So that set, reset become your thresholds for the input, and then set, the output, is your should I continue to be on or should I continue to be off signal. don't make a further loop, otherwise it all goes to hell. And that's it. Thanks very much for watching. Hope you enjoyed. Like and subscribe if you did enjoy it. I'm not really a circuits wizard, although I'm a software engineer by trade. I find the temporal logic of circuits a little bit baffling. But anyway, that's it. Bye-bye.